Next up, we have Spiros and Constance from Omnition with a sort of different twist on the space. Thank you.
Hello, everybody.
Good morning.
Hopefully by now you're convinced that tracing is very important. We believe it's actually fundamental for monitoring and troubleshooting microservice-based applications. It's kind of the underlying fabric that connects all telemetry together. And we also think that, for the most part, we've been doing it wrong so far. And hopefully our talk will, for those of you building systems in particular, inspire you maybe to question assumptions. So my name is Spiros Xanthos. I am one of the founders of Omnition. We were an observability and distributed tracing startup. We were actually just acquired by Splunk last week. So I'm no longer a founder, but I've been working in this space for quite a while. I previously built a company called Pattern Insight, which built a log analysis tool called Log Insight that also VMware acquired back in the day. And subsequently, I started a consumer company in which we ended up building, let's say, microservice-based applications, cloud-native type of applications. And that's where I experienced firsthand the limitations of the prior generation of tools that I helped build. And that was the motivation for me to start Omnition.
So previous to Omnition, I was at Lyft. I was one of the core maintainers for Envoy, which is a networking proxy that really makes networking transparent for those who don't want to know about networking, because I imagine most of you in the room don't care about networking, only when it fails. And so a lot of my time spent at Lyft was, one, either making sure that everything was working, and so I would get paged many times in the middle of the night, definitely at 2 o'clock in the morning, right in the middle of my REM sleep. And that was definitely very frustrating, right? We would have a massive amount of logs and metrics, and I could tell that there were issues, but the correlation part was always missing. The other part of my time at Lyft is I would spend a lot of time trying to educate engineers how to better use the metrics and logs that we provided, so that way they could become super users in terms of being the person that could handle on-call and figure out where things are coming from. So what we're going to talk to you about today actually would have made my time at Lyft a lot easier. I wouldn't have had to spend hours training engineers to figure out how to correlate one error from one service to another. There's a really nice way to do that, and believe it or not, that's with tracing. So as Adrian Cockcroft said it best, Death Star topology. Microservices are great, especially from an engineer point of view. It allows a lot of independence. You can deploy whenever you want or need. You are no longer tightly coupled to a monolith. There's all these benefits there. There are, however, some downsides. As you get bigger, there are a lot of complexities. Networking, infrastructure. So apart from managing it, which is very complex, which is its own talk in itself, there's a lot of actual pains for the application developer. And this really comes down to when being on call.
So we want to talk to you about some of the specific pains that we have seen in a lot of the companies we work with. And I want to highlight 2 things. So these pains tend to be often around availability, not just performance, because for the longest, I think we have been thinking of tracing mostly as a performance troubleshooting tool, but we claim that it's actually ideal for troubleshooting availability-related issues. And secondarily, these are problems where tracing is the best way of kind of monitoring and solving them. So when you're dealing with a microservice architecture, which oftentimes is very deep, something goes wrong. Oftentimes that propagates upstream, even downstream. Many of these services are probably being monitored. All the thresholds of the KPIs you're monitoring are being violated, so you end up in kind of an alert storm, oftentimes in a war room, trying to figure out where the problem came from. So this is what we call a who to wake up kind of challenge in a microservices architecture. Even if you can actually, let's say, connect the dots and understand where the problem, or isolate the problem, understand where the problem is coming from, it's still very challenging to figure out what the root cause was. In our experience, the root cause 80% of the time ends up being like some sort of a change event, a code push, an infrastructure change, a configuration change. But because we're talking about highly distributed and highly dynamic systems where code gets released all the time, it's difficult to connect the dots even if you have isolated the area to where the specific problem is, so you can solve it, the way kind of Yuri described. And finally, oftentimes the systems for which you care about the most are systems where our users interact with, and problems happen, let's say, in upstream services. It's oftentimes very, very difficult to understand which users are being impacted and how are they impacted by performance or availability problems that might be happening. Now, why, let's say, the prior generation of tools by itself is not sufficient? So metrics and logs are great and remain actually extremely useful, but by themselves, they're not enough anymore. So metrics are great. For example, pre-aggregated metrics are great for understanding the end-to-end behavior of an application or understanding how a particular service behaves, microservice. But when something goes wrong, you're out of luck because you need to connect the dots on your own about where the problem might be. Similarly, with logs, they're great for troubleshooting or figuring out what's wrong with a particular service or application, but they lack the context for a lot of the problems that come up because of the interaction of services. And how about tracing? Going back to my previous claim that we've been doing it wrong for the most part. So there are a few things that I think have been assumptions, established assumptions, that I believe are not the right assumptions anymore. First of all, I think we have approached tracing pretty much in a very bottoms-up fashion, similar to how we approach log analysis. We take traces and spans and index them, and then we usually provide a query interface where we try to find outliers. And then it's usually back to the developer to try to figure out by examining, let's say, individual traces, what the problem might be. So they have to state a hypothesis and kind of manually verify the hypothesis. When in reality, traces, because it's much more structured than logs, have the ability to be aggregated and be looked in a different way. The second established kind of assumption is that sampling is essential. So unlike logs, where we actually collect everything, with traces usually we end up sampling heavily. And we think that, and we've seen in practice, that this is usually unnecessary. There are cases where you cannot collect everything, but those are actually the exception, not the rule in our experience and opinion. And finally, I would say a collective failure of our industry is that we made our users very, very extremely aware, actually, of cardinality. When in reality, I think we should be building systems in a way that they gracefully handle this, right? Either by pre-aggregating what can be pre-aggregated and maybe on the fly aggregating everything else and having kind of the smooth transition between the two. And I would say most tracing and metrics kind of observability tools today kind of suffer from this problem. And now I'll briefly introduce you to our view of the world, and Constance can give you more specific examples about how we're thinking about it. So in contrast with what I just described, I believe that full fidelity is feasible, and once we implement it, we have many, many benefits. First of all, tracing now becomes much more useful for troubleshooting all sorts of problems, and we can capture every corner case and every failure in the system. And not only that, actually, we can give confidence to our users that they can trust the system when they go look for something. Because unlike, let's say, a log analysis tool, where usually you find what you're looking for, most of the time, if you're trying to use a tracing or trace search tool, usually you fail to find the trace you're looking for. And after a few attempts, users oftentimes get disappointed and stop using it. We also believe that by taking the right approach around cardinality and aggregation, with a smooth transition between pre-aggregated and on-the-fly aggregated data, we kind of can eliminate this need for the users to be fully aware of cardinality limitations of our systems. And finally, and maybe the most important, is by taking a more top-down approach, which is actually feasible with tracing, because we have, as I said, very structured data, and we have all the causality information in the data itself. We can actually aggregate the data in a way that instead of users having to state hypotheses and ask questions, the system itself can possibly guide them to the answers. And furthermore, this approach actually eliminates the need for developers and SREs to become experts in tracing to solve their problems. They can focus on being experts in the application they have built and use, let's say, a tracing tool just to assist them in monitoring and troubleshooting whatever problem they have at hand. And with that, I'll pass it back to Constance, who is going to give you more specific examples.
Yeah. So let's talk about top-down first. This is a view of an application of the top-down using all tracing data. you'll actually only see one slide with traces. Everything else you're going to be seeing today is going to be a visualization of your application using trace data. Now, this is showing a happy application. We're using the concept, if you see red, red is bad, stop. And so since we see no red here, we know that everything is working out well. This is also a really good place for us to see latency. Every edge will tell you what the P90, we're using P95 in this case, but it can be any of the latencies, any of the PNs. And this can show you what the rough latency is here. Now, just like deploys like to happen on a Friday afternoon, errors love to happen in the middle of the night, right? So we're definitely, we'll get paged in the middle of the night, and then any service that is on a call path, say, in this case, recommendation service is causing errors, anything associated with recommendation service is probably going to page as well. Unfortunately, this leads to everyone getting woken up. Now, what is really common right now in the industry is that we'll page on success rate of a service. What is the weakness of this is that it only gets us the metrics. It's only telling us if a service is seeing errors. It doesn't differentiate between is a service actually causing the errors, originating the errors, or is it propagating it? So as Spiros said, right, tracing, well, actually, as Yuri said and Helga said, traces are very, very powerful. Right? We get the full context of a transaction. We can see what services are involved in it. We can see actually where errors happen. So in the old world, all of the services here, front-end, checkout service, currency service, would page because they're all CF503. However, when we analyze a trace, we can see when the error starts. And when the error starts, that's the one that's originating the error. So let's differentiate. If it's a solid red, that is the service that is actually originating the error. And we can do this for all traces, well, for all services. Since we capture all traces and on all dimensions, we're actually able to differentiate between a service seeing errors and then after which ones are causing a root, or which one are actually root causing. So instead of paging on actual errors seen by a service, we're going to erase that. We're going to start paging on root cause. And tracing is unique to this. Metrics and logs are powerful. However, they don't give you the context, right? That is always a thing that is hard to get. When I've spent a lot of time training at other engineers at Lyft, is I would teach engineers, follow the hop from the first error seen to the next error and error from service to service. And we'd always assume that the last service that didn't have, the last service in the hop that started errors was the one originating it. And so that's very much like this. But we have more of the guarantee because we can actually see the context of each service hop. Now that we know that currency service is actually returning errors, we're naturally going to want to figure out what's wrong. Oh, that's a bug in there, but that's fine. So what we usually do, just like with logs, is that we're going to try and find an example of a trace that has an error. So we see right here that currency service is returning a 503, and we're looking at the operation get conversion. Usually this is where we say, hey, I think this is the issue. I'm going to find other examples of get conversion and see if there's an error. Unfortunately, when I look at another trace, like the one below, there is no error. And so that immediately disproves my hypothesis. And as Obi-Wan Kenobi said, these are not the root causes you're looking for. Thank you for the giggles. So let's talk about tags and traces. Just like what you'll do in a log, you'll add a lot of metadata. Environment, version, you can put HTTP path, anything related to the request. You'll do the exact same thing within a trace. Why this is important to put it into a trace is that this will allow you to pivot on that top-down view that I saw earlier, that we showed you earlier, to actually be able to figure out what's going on wrong. So let's actually start investigating it. One thing I commonly do when I'm investigating an issue is I'm going to look at environment. One thing we see here, so on the right-hand side, currency service is broken up by environment. And this was a tag in the trace. So we see development, production, staging, and then we see the services that call into it. Unfortunately, what we can see here is that all environments are experiencing errors. So that doesn't help us narrow down where the potential issue could be. So let's try a different dimension or a different tag. What about region? OK, this is better, right? US East 1 isn't experiencing any issues, but US West 1 is. Since the entire circle isn't red, solid red, I know there's a little bit more to it, so I want to break down even further. And so what I do is I break down that region even further. And I actually see that it's one particular instance. How this differs from normal debugging is that usually if you either have metrics per instance or if you do it logs, you're going to be trying to look at each one of these things here and say, for what I used to do, is I would use wavefront and say, okay, is this particular instance returning 503s? Maybe, I can't really tell, right? Is it a snapshot, or is it region? And breaking all those things, but I have to manually create those queries. Using traces and actually all dimensions and full fidelity, yes, all the 3 points we're talking about, we're able to see really quickly all the different ways that these tags can actually be causing errors. And so for the purpose of this, obviously it was each slide, but this is something you can do within 3-4 clicks. You just look at a service and you break down by a tag, and then you quickly see if something is wrong or if that's potentially an issue. Now that we actually know that the currency service is causing errors, let's actually talk about how does it impact the system. This is always a hard part, right? Something 4 or 5 hops down could be causing issues, and everyone else is returning those errors. And so as I was saying before, checkout service, front end, those are paging as well. But as we just talked about, we can now differentiate between root cause and errors. Errors being the older way of saying, does a service see errors? So right now in currency service, we know that it is originating 25% of the errors, so we're definitely going to wake this team up. They have something wrong, they need to fix it. But what about checkout service? We actually differentiate between root cause and errors by using a shaded red versus a solid red. So I am walking through this manually, but going forward, once you understand this, you no longer have to actually dig deep into it. We see that there are 17% of errors, but there are no root cause. So in the middle of the night or any time, there is no point in waking up the checkout service or paging the checkout service if the currency service is the one that's actually causing the errors. Let's follow it back up. Same thing with front end, right? This front end is experiencing quite a few numbers of errors, but it isn't the one that's causing the errors. So once again, we actually don't need to page this team to handle it, since currency service is the one responsible for it. Back at Lyft, on the networking team, we were responsible for the front end. And so the amount of times we used to get paged because we were seeing someone else's errors was a little tiring. So this would have definitely saved me quite a bit of hours of sleep and wake-up calls. But now, let's actually talk about customer impact. Right now that we say we know we have an error, the next hard thing to figure out is if I have a bug, is it important for me to fix it in the middle of the night? Is it even important for us to investigate going forward? Right? And this is where usually customer impact in business cases come into account. This is a top-down view of the entire application, but scoped to a business scenario. In this case, it is a checkout. And so these are all the services that are related to checking out a user. As we can see, there's definitely the currency service is, solid red. It is causing errors. And we see the checkout service is forwarding them and front end as well. But how does this actually impact our customers? Now, this is going to be the one time where I'm going to say pivot away from looking at root cause. But we want to look at the actual errors in the front end. So this error here, percentage, is a percentage of users who are using the checkout service or checkout customer flow that are experiencing errors. Now that I actually know how much this issue with currency service is impacting my customers, this can help us to better determine, do I push that code change at 3 o'clock in the morning? Do I bother investigating it? This can actually give us the details and the power to say, am I doing the right thing? Or even then, you can use this to push back, right? If you're developing a new API, you can see if things are flowing the right way. Or if you have a new feature, this is how you can show that this feature is actually getting a lot of traction. And so the last point that I really want to make is that this is all using trace data. All of this is possible because we are capturing every single trace. We are not doing any form of pre-aggregated data aggregation. And why not doing any pre-aggregation allows us to pivot on any of these dimensions at any point so we can figure out what's going on. And we're doing top-down, right? We're using the errors and how the service and the applications are interacting to guide where we're seeing things, instead of coming up with a hypothesis and then after building that going forward. Now that we talked about the amazing things with traces, you're probably all wondering, how can I get into that? How do I get tracing stuff? And so with that,
that's just a quick call to action. It came up before, but Omnition is one of the contributors to OpenTelemetry, and I want to encourage you all to take a look. The first release is coming up soon. You're welcome to try to contribute if you're interested. It's an effort trying to democratize instrumentation and data collection in a vendor-neutral way, so you can control the data and use it in whatever way is meaningful to you.
We love contributions. Please contribute. There's more work than engineers available.
Thank you.
Thank you, everyone. Oh, wait. Oh, one more. Yeah. Follow us on Twitter. We'll mostly follow Spiros because I don't tweet very much. So.
Me neither.
Thank you, Spiros and Constance. We have time for a few questions. Right over here to start. The mic is on its way.
Hey, how you doing? So I'm wondering what happens when errors are occurring, but the system can't pinpoint the root cause of a specific service, or how frequent does that happen with this product?
So then, usually at that point, they're either unfortunately, it does require a little bit of initial work, in terms of tagging your data, because if you can't pinpoint it, you probably don't actually have the right form of ways to pivot on it. So.
I mean, in my experience, this doesn't happen often because usually you can explicitly say if an error has happened. I mean, it might be an instrumentation issue. But the beauty of tracing is you have the full causality information. So usually you know when a problem starts, how it propagates, how it escalates. So if that happens, it's usually because of a problem in instrumentation and not really something else.
The good thing is that at least it narrows down your problem scope, right? That's usually, depending on what infrastructure tools you have, a lot of people's first issues is where do I even start to debug? And so at the very least, if you know, service A or some component is one with solid red, but you can't break it down on any dimensions that help you, at least you now have narrowed down the scope by whatever fraction, however large your system is. So that does make things definitely incrementally better.
Thanks for the question. Thank you. More questions? Yeah, right here in the middle.
Hi.
Hey.
Obviously, when dealing with problem, having more relevant information is always useful, right?
Yeah.
You guys are very ambitious in collecting all traces.
We are.
I wonder what are the implications of doing that, of this approach, both in terms of performance of your system and storage. I guess there's no free lunch, right?
No. So actually, I guess the thing I want to maybe highlight is that really the real limitation of collecting all traces is in the application itself. So for very high, for services that handle a very high number of requests, sometimes it might not make sense to do that. Like if you take Omnition as an example, so we have a data ingestion path and a user query path. For a data ingestion path, usually it doesn't make sense to collect everything because it's just lots of data flowing through. But that should be the limitation. Because I think there is maybe an established assumption that I should generate all this data and then throw it away by sampling. I think that's what we think is wrong. In fact, actually the cost of collecting, transmitting, storing all these traces is insignificant, in my opinion, compared to the cost of actually generating them. So generate as much as you can. If you can generate all of it, do it. And usually that's feasible for most services. And once you do that, it's a wrong trade-off actually to throw away the data. It's not that much more expensive than doing logs. In fact, it's probably cheaper actually because you don't have to index everything.
Yeah. In practice of the back envelope math, it's really not as scary as people think it is.
This sounds like a good one for happy hour.
Whiteboard challenge.
Let's do one more question. Yeah, right back there.
Okay, so something that I think I've noticed this morning is that vendors like Omnition and Lightstep, they're into full fidelity. People at companies like Uber and Facebook are talking about sampling. So it seems like people who are trying to sell a product are trying to sell full fidelity, and people who are trying to solve problems are using sampling. So how do you reconcile those two views?
I can start with that one. Yeah. So I think there's definitely a difference in between, right, like Uber, Google, Facebook, they are massive applications, right? And what we're saying earlier is that they're actually, kind of how you always ask, is this trace an outlier? They're mostly an outlier compared to the rest of the industry, right? And so, like, for them is that they actually don't, like, for them to be able to transmit that data, it would, like, they would have to store petabytes every day. Like, nothing on the internet can necessarily, like, very little can actually transfer that. But what's actually common for a lot of applications, and like for engineering topologies, is like you actually have, maybe a few hundred services, you may be doing a few million requests per second, and that's really feasible to actually store everything and analyze it after the fact.
And I claim we're capitalists, right? But we're trying to sell a product by building the best product. It's not like we're doing it because we have the wrong incentives here. And I think definitely Facebook and Google are the wrong examples, in my opinion, in terms of volume to apply to everyone else, because they're actually orders and orders of magnitude far away from what everyone else is.
Great. Thank you very much for the questions and the answers.